Greetings folks and welcome to the Electromaker show. This is your roundup of all things maker and embedded and lovely on the internet, and we talk about projects and new products and some crowdfunding campaigns on here, all based around that sort of Arduino end of the spectrum. Whether you're using the Arduino IDE for the very first time and learning to code, or you're getting deep into the ATmega328P datasheet, or using a Raspberry Pi or any other controller and cool thing like that, this show kind of tries to cover it all to an extent. Now last week we had our Crowd Supply special, and Crowd Supply is a funding website, so I thought this week it would be nice to focus on projects and products, and that's exactly what we are going to do. We'll be talking about the nPM fuel gauge from Nordic. We'll be talking about a new ESP32 C6 development board, which might be the perfect way to start your DIY smart home, a very powerful browser simulator, and also some fantastic DIY synths using microcontrollers, which I'm very excited to talk about. So with all of that to get through, let's start the show. We're going to begin this week's show by looking at the nPM fuel gauge from Nordic Semiconductor, released just a little while ago. Now this is a battery profiling board, the idea being that you can get a full profile of a battery that you plan to use in your project, so that when you actually test it within your project you have an idea as to how it should be performing compared to how it does perform with your hardware and software that you have written and made. Power in general is something that I come back to from time to time on this show, because we're very used to looking at microcontrollers or system in package or amazing connectivity and sensors and all of that. But the backbone of every project is power. And even if you're making something that is planned to plug into the wall, a very old electrical engineering maxim is power spikes when you're not expecting power spikes usually means something is wrong. And you should probably look into that because it may come back to bite you later. But yes, the nPM fuel gauge in essence is a board that allows you to take a full profile of a battery in controlled settings, so that when you do actually start using it, you will be able to have some insight into whether the issues you are having are down to your project specifically, or maybe down to a dud battery. Now, we've looked at other battery profiling solutions on the Electromaker show before. This one is a little different in that it is something that fits in Nordic's ecosystem. And there's a number of advantages and disadvantages there. One big disadvantage being that if you're not using a supported power management IC, then you can't use the nPM fuel gauge. However, the other side of that is that this is designed specifically to work with Nordic's nPM PMIC 1300, I think is the designation, something we talked about when we visited their stand at Embedded World, meaning that you get a very high level of accuracy. But essentially the board itself, as you're seeing here, is a constant current sink that allows you to drain batteries with a very high degree of accuracy and measure exactly what happens in those moments. And there are a number of advantages for doing it using this method. Reasons which Nordic have very usefully put on the nPM fuel gauge page that you will find linked in the description of this video. But in short, the cons I've just mentioned, it needs to be supported by the power management IC, but the pros are incredibly high accuracy and ultra low power consumption compared to things like open circuit voltage measurement, which uses no energy at all but isn't particularly accurate, and column counting, which does actually consistently pull a draw that you have to account for. However, a definite advantage of the nPM fuel gauge is that it fits into Nordic's NRF Connect desktop suite. So if you're not familiar, there's a whole variety of things you can use Nordic products with, and I usually skip over this to an extent. I usually mention that they have this fantastic SDK, which is based on Zephyr, and long-time watchers of the show will know that Zephyr is something that I am equal parts fascinated by and terrified of because of its complexity. But Nordic really have gone some distance to try and take away some of that complexity, partly by making the SDK very accessible with things like additions to VS Code that make it easy to understand device trees and things, and partly by the fact that almost everything that you can do with those boards you can do with a visual GUI. And this is a perfect example of that. This is the Power Up software from Nordic, which you get from the Nordic NRF Connect menu, and you can get that by just downloading NRF Connect from Nordic. I don't have any of the things connected right now. I at some point soon would like to do a full proper review evaluation of kind of one of my Nordic dev boards with a power management IC, with the fuel gauge and a battery, to sort of really show a step-by-step way through of doing it, I feel like that would make a very nice tutorial or something for the Electromaker projects page. But for today, this is the software. However, I'm going to jump back over to the Nordic tutorial for how you would generate a battery model, just really talk you through it very quickly to give you an idea as to what this board can do. So here they're pairing it with the nPM 1300. Again, this is something that we have talked about in the past. There is an interview from Embedded World with Robin from Nordic Semiconductor talking about the power management IC. And it's a fantastic interview which goes both into some good technical details, but it also draws right back to basic principles about power management ICs. It was actually one of my favorite interviews we did at that time. I will link it in the description. But yes, if you want to generate a battery model, the idea is that you connect the fuel gauge board to the power management IC. And the IC itself, by the way, is absolutely tiny. It combines a bunch of different power management stuff into one little chip. That in and of itself is great. We'll come back to talk about that another day. And then you connect your battery, choose what type of battery it is, and you give it various different things to test and profile. So how will it perform at 5 degrees, 25 degrees, and 45 degrees, for example? Now, you are actually just using the battery at your room temperature. That's the calibration point. These are data points that are created by the nPM fuel gauge. You can run this, and once it has run, you just get a JSON file, which has all of the battery profiling data that you need, that you can then put onto the system on chip of the nPM 1300, which is the host controller of the IC. So if you're using the IC in one of your projects, that would be your host controller. It would just be one of the things that it does. And then you have a fully functional battery profile, so you know how the battery should behave, and you can see that any times that it does not behave that way, you can look into maybe a design decision you have made or a software decision you have made and get it really working to a fine, crisp. Crisp is a weird, really get it working finely, properly. The point is, it's the difference between making a prototype battery product that runs out in a couple of hours or several hours down the line, because big mistakes can be missed. And this kind of profiling software is invaluable. Yes, you can do this with things like a multimeter, or if you have a very fancy oscilloscope, you can do some profiling on there. But this allows you to automate that, generate files, and give yourself a real kickstart when it comes to the power aspect of your project. So pretty much you don't have to think about it too much again and concentrate on the really pure stuff, which is developing it to be exactly what you want it to be. Now, there is more to be said about the nPM fuel gauge, but I feel this is enough to really give you an idea as to something, whether you'd be interested in finding out more about it or not. It is something that we sell in the Electromaker store, and I will be linking this page along with the interview from Robin and the main page of the nPM fuel gauge, so you can look into it further if you would like to. And this would seem like a good moment to remind you that Electromaker does not put any monetization on its YouTube videos. If you ever see an advert on YouTube before one of our videos, that money is going straight back to YouTube. We turn monetization off. So if you want to support this show directly, the best way that you can do so is by shopping in the Electromaker store, where we stock the nPM fuel gauge along with a massive amount of things from a huge amount of different people, as you're seeing all of these names streaming across the top of the shop page here. We don't just stock brand names like Raspberry Pi and Arduino, we also stock from third-party stockists. So for example, we stock everything from Adafruit, everything from Sparkfun. If you would like to support us, and I suppose by proxy them, buying it through our shop is a great way to do it. But of course, as always, if you are just here and enjoying the YouTube show, doing all of the YouTube things like liking the video, leaving a comment to say what you liked or didn't, and making sure you're subscribed to the channel is all much appreciated. Just very briefly, CHLohr or CHLohr is a name that some of you may already know. We've certainly talked about him on the Electromaker show a fair amount. Charles is the person who managed to make LoRa work using GPIO pins without an aerial. He's also the person who wrote the toolchain for the CH32 V003. He's one of my favorite creative coding YouTuber type people. Anyway, he put out a tweet saying that he essentially got a couple of gimbal motors working directly through the pins of the CH32 V003. Which is incredible. Now, he's only pushing a very small amount of current through because you don't want to run a motor directly from GPIO pins. I think that's a mistake many of us made very early on. But if you are interested in finding out more, I'll leave a link to the tweet and the accompanying GitHub page. It is very interesting the way he's doing it. He's essentially using the PWM signal and then reading it through the ADC to essentially filter out all of the noise, which is a fascinating way of doing it because he's essentially creating a comb filter. And I don't know if you've ever heard a comb filter in audio, but they sound wild and wonderful. And actually using it to create less noise and destruction is the opposite of what I am used to, because in the music world, comb filters can get you some pretty nasty stuff pretty quickly. Up next, we're going to be looking at a project on the Electromaker project hub from CE Tech 11, and they have created a system that allows you to voice command your NeoPixels or your addressable LEDs, your WS2812Bs or whatever they are. But this is an offline voice recognition tool. It is a tiny little module, so we're going to sort of combine this section. We're going to look at the wonderful project that CE Tech 11 has put together, but we're also going to look at the module itself, because it's showing up in a lot of different projects with microcontrollers or with system on chips with single board computers, and it is a very cheap little module that does quite a lot. So I think it's time that we shone a light a little bit on the DFRobot Gravity offline voice sensor as well. But before we do that, let's look at this project. So this is voice controlling NeoPixels, and it kind of does what it says on the tin. What we have here are three things. We have an Adafruit NeoPixel ring, the DFRobot Gravity, the offline language learning voice recognition sensor. Gravity, by the way, is the name of the series of sensors that DFRobot have put out. They're all a set of modules that can work with various different microcontrollers and do different things. And this is their offline language learning voice recognition sensor. And they have an ESP32 development board, this time using the C3, and it is again a DFRobot Beetle. And the setup, as you can see here, is relatively simple. You have the little ring of NeoPixels over here, although this could be, of course, any kind of addressable LEDs of any amount. Rather than thinking of a ring of NeoPixels on a breadboard, you could think of different sets of LED lights, whether you have bought addressable LEDs in an enclosure or not, or you're just completely DIYing it at different spots. And again, all you need to think of in terms of this controller is any ESP32 development board. That's the beauty and modularity of this project. Now, the project gives example code for every step of this. Here, this is just testing the NeoPixels, so no actual voice commands or anything like this. This is just checking that you've connected them to the development board correctly, and this will just turn all of the pixels off, and then it will turn them all to green. So this is all this is doing, and as you can see, the NeoPixels are working fine. But the real star of the show here is the Gravity voice recognition sensor. So, as it says, this is an offline voice recognition sensor. It is capable of learning a few, but crucially enough, phrases to give you a little bit of modularity, a little bit of granularity for your code. It basically gives you a few hooks that when it hears the correct wake word, it will reflect that in the code and change a variable or whatever, and then you can make a switch statement about those variables. I wonder how well the noise cancelling that I'm using for the fan does with helicopters, because there's one right outside. The project also covers how to add custom wake words to the offline voice sensor, although there are something like 150 phrases already built into it that it is ready to understand. There's also a speaker as well, which is useful because one of the bits of code here will actually say the wake word to you, depending on which ID it has, which is a great way of sort of debugging what you were doing. But yes, this adds a few custom words like lights on, lights off, lights to red, and lights to green. And this, as you will see, well, works.
Hello, robot.
Yes, I'm here.
Lights on.
Okay, got it.
Lights to red.
Okay,
Lights to green.
done.
Lights off.
Doing it.
I still get such a kick out of seeing things like that. As much as that is a simple demonstration of how you can get a little bit of granularity in your code through voice recognition, yeah, I get very excited about simple things. But the point is, this will allow you to add offline voice recognition to a massive variety of projects. It doesn't take much of a jump of imagination to think this alone is a fantastic idea. It allows you to add a variety of different color profiles, because if you think about it, lights to red, lights to green, that could actually just mean, you know, daytime lights, and it gives you the light shade that works best when there's light outside. Then nighttime lights, and maybe gives you a slightly nicer on the eyes light for the evening. Phones and computers have night mode, why not our homes? That's something that you can program and get up and running incredibly quickly without having to worry about large language models. Well, that's not the right thing, is it? Speech recognition tools that take up a larger amount of space and processing time and power, crucially, as well. So yes, the offline language learning module is one that I've seen crop up in more and more projects, and I think it's a real peach. Like, there's things that show up every now and again that are just astonishing for the money. This is a $15 module, and yet it can connect via I2C and UART, I believe, or maybe it's SPI and UART. But either way, it has, you know, simple connectors on the side allowing you to attach it to whatever you want to. These things are very easy to break out as well. So if you're working with pins on one side and a connector on the other. Most things come with a variety of different cables anyway. If not, it is very, very easy to kind of make one of those up yourself. I have pulled several stemmer Adafruit connector things apart just to get at the basic wires in the past, and yeah, I am no professional and I did not find it particularly challenging. So I'll leave a link to the project in the description. Please go and give it a look. It is, as I've said many times, it is not necessarily the highest complexity projects that jump out to people when you put things on Electromaker, and I highly recommend, if you're fiddling around with something and learning how it works, to document that process on the Electromaker project hub, because this particular project alone is fantastic, but it has the seeds for so much potential, and I hope that it inspires you to add just a little bit of that voice recognition, but in a very small sense, to your DIY home automation setup. And of course, I will leave the shop link in the description. I believe I've already given the spiel this time, so I won't say it again, but if you do buy it from us, it supports the Electromaker show, which of course would make me very happy. Now, no prizes for guessing what we're talking about next on the show. This pair of glasses that I am wearing has a bar coming out of the side with a prism screen on the front, which is currently showing me the time, although it happens to think it is 8:20 in the evening. The star of the show, of course, is the screen, but this is essentially an ESP32 development kit that comes in the form factor that fits on these glasses that also come in the kit, without any lenses in, of course. So the ESP32 development board is connected up to this AMOLED display reflecting on the prism. It also has a microphone, an IMU with some kind of AI addition to it. I haven't really looked into that as yet. A microphone and a little context switch here that you can use to switch between the different modes on it, but I haven't quite got the hang of it yet. So currently, this is showing me the pitch and yaw in the direction that I am looking, and hopefully you're seeing a couple of other shots on the side of the screen here that I took of it when I got it. So I got the T-Glass directly from LilyGo. This is not a sponsored section or anything. They didn't ask us to look at it. This is just Ian saw something cool and bought one. It is an ESP32 S3 based device. And what you get is what you see here. You get the glasses, you get the bar as well. You get a little box for them to come in, and you get all of that for $41, which is more expensive than some ESP32 based development boards, of course, but this is something a little bit special. So, it comes with the ESP32 S3, the FN4R2, I'm assuming it has to do with the fact it has 4 megabytes of flash and 2 megabytes of PS RAM, but I'm not certain of ESP32 designations without looking them up. It has wireless protocol. Yes, ESP32 S3 can do Wi-Fi and Bluetooth Low Energy, so you can use it for that. And the onboard functions include a microphone, a real-time clock, and a touch button. I'm not absolutely sure how the whole button thing works, because you can swipe past this end part here and get to different parts of it. I'm wondering if it's just... Oh, it might just be the inertial measurement unit that's doing that, actually. Maybe that's it. Yep. When you tap it, it changes the screens on the demo. And it mentions 2 separate resolutions here. I'm not really sure exactly what that's about. I'm assuming that what I'm getting here is the 294 by 126, and it is full color because the demo of the battery life remaining is in color. There's a very vibrant green color on it. And in fact, if I tap until we get back to it, and I put the camera in just the right way, you can see a sort of blown up larger version of it. If you look in the prism right now, you can see, yeah, I have 3.75 volts. Of course, it is reversed for you. And if I'm trying to trace the side of the circle. Not particularly easy to do, but yes, I'll show you it in a picture as well so that you can see it. Now, the glasses also incorporate an inertial measurement unit with 6 axes that has self-learning AI capabilities. And exactly what that means, I'll be honest and say, I don't really know. I did look up the sensor number. They note it here, the BHI260AP, and the page that Bosch have about it doesn't say an awful lot. It says it provides an ideal all-in-one solution for always-on sensor applications such as fitness tracking, pedestrian positioning, machine learning analytics, and orientation estimation. It's a smart sensor that includes a wide variety of software functionalities, a 32-bit customer programmable microcontroller, and a 6-axis inertial measurement unit all in one package. And it talks about self-learning AI software and swim analytics and all this kind of stuff, but doesn't really go into much detail as to how it does it. And yeah, the video with it doesn't really help either. It's more just an example of someone using it. And again, the technical data kind of says it has self-learning AI function at different kind of things. Exactly how it collects that data and what it does with it, I'm not 100% sure. It's something I will look into in the fullness of time. But I suppose an important question to answer would be, as someone who has got one of these, and it's not a kind of a sponsored thing at all, would I recommend getting one as a development kit? Well, the simple truth is my first impressions of this are mixed, because I didn't just get this for its display. Like, don't get me wrong, I really love it. But I am, for example, a big fan of Zack from Voidstar Labs. And he has a really wonderful little display that fits just in front of his glasses. He uses it as a teleprompter, and he's got a whole amazing video that he came out a few years ago now about trying to remake it, make a new one, and the various problems with the commercial products that already do this. And bear in mind that he's using parts which each one of which costs significantly more than this entire development kit. However, if I wanted to use this as a teleprompter, I think I would get a headache very, very quickly, because there's no way that you can focus on it in any way that that would work, you know, in front of a camera. You either really need to put one eye closed and look like this, or really put your eyes together like this. And bear in mind, this is me looking at the time on here, which is medium sized. But if I switch this over to show all of the inertial measurement stuff, even with one eye closed, squinting the best that I can, that text is just far too small for me to read, no matter what distance away it is from my eye. And as far as I understand, as far as I know, my eyesight is still pretty good for someone of my age. Maybe I will go to the optometrist and come back and say I was wrong, but yeah, putting this any closer to my eye does not help the issue. It does need to be further away, but when it is further away to the point that I could focus on it, yeah, even squinting as hard as I can, I just can't make out that text. It is too small. So from that perspective, really this is exactly what you pay for. If you think you can get $40 AR-ish glasses that you'll be able to read from while you're walking around, unfortunately you get what you pay for, and you need to pay much more than that for it. However, I have zero buyer's remorse with this whatsoever, because the Prism screen is okay. It may be something I use. I might look into a way that I can take it off and put it back on. I'm going to mod these heavily. I don't really have any need for the main glasses. I'll swap these out for sunglasses at some point. But the ESP32 with the microphone and the inertial measurement unit is very interesting, because for someone who is interested in data and moving it around and all that kind of stuff, the idea of having an inertial measurement unit and a microphone built into my glasses that could pump that data out via Bluetooth Low Energy in real time, and it has a battery already built in, all that kind of stuff. Now that's interesting, because, and those who predicted Ian's going to turn this into a music thing, all right. The ESP32 itself has a DAC on it, so you could actually generate sound directly from these glasses if you wanted to. But what I would probably do is take all of that nicely AI smooth, that's been learning by itself somehow, data and microphone data, pump that out via Bluetooth Low Energy to something that I happen to be carrying on me, be it a phone or a Raspberry Pi or anything. And that would be able to decode that and turn it into sound in real time. I have said it over and over again to many, many people. One of the few things I really dislike about modern fitness watches is that it keeps all of that data in the watch, and then it'll put it on the phone. And with my particular brand of watch, the only way that you can get that data is by logging into a very clunky web interface, downloading the files, and then decoding the files yourself. I would much rather just have the data and do something with it, and this is one way to be able to do that. But yes, I'm not going to give you a you should get this or not, because everyone has a very different idea about what they want to do with stuff. Personally, the screen is a letdown for me, and if you're getting it for the screen, which, let's be realistic, is the main draw here, I would probably wait until something else comes along. But to have a fully battery-powered ESP32 development kit, essentially just in this stick, is kind of an amazing thing. Let me just pull the glasses out of it. This is essentially what you're looking at here. This incorporates all of it. It has the on-off switch here. It has the push button on the top. And this is a fully 3D printed arm, by the way. There's no reason why you couldn't change this up and do something different with it. I'm yet to open it up and look exactly look at exactly what the innards are. But when I do, we'll probably talk about it again on the show. Moving on, we're going to talk about the ESP32 C6. Now, when this chip first appeared, it was quite an exciting thing for a number of people, and for good reason, because it combines a lot of the things that we love about the ESP32 already, which is that it is quite fast. This one actually works with a high power and low power core, the high power core being 160 megahertz, the low power core being around 20 or something like that, with of course all of the connectivity that you expect from an ESP32. But it is also a RISC-V chip, and it is set up specifically to work with home automation protocols like Zigbee, Matter, and Thread. And now there are a number of development boards out there featuring this particular chip, and there are many to choose from. They all have their advantages. But one of them that recently grabbed my attention is something that I saw on CNX Software, which, if you are looking into getting into DIY smart homes and specifically working with Matter, Zigbee, and Thread in a more DIY way, this board might be exactly what you're looking for. And in case anyone was wondering, this is just the splash page for the ESP32 C6 that I put up before. I'll leave a link to that in the description just in case any of you would like to dive specifically into this chip, because as I said a moment ago, what we're about to look at is a fantastic development board, but there are many. And if you're just interested in finding out about the system on chip first and then looking into exactly what peripherals and stuff you want on a development board, you could of course do it this way around. If you look under the features section or just kind of head down to the bottom, you can head to the main page or look at the different modules and get the data sheets and everything that you would want that way. However, we're going to jump over to the always fantastic CNX software to take a look at the Maker Go ESP32 C6 evaluation board, which has a quad relay setup on it. Now, anyone who has dipped their toe into any kind of home automation knows that the relay is absolutely your friend. Not everything you have is already a smart device, and even things that can be controlled in a smart way, sometimes you just want to get into the signal path of the power running to an object and disturb it, turn it on or off, however you wish to. Now, this is the not mandatory, but the warning that I do give every time. If you are starting out doing this and you do want to, for example, turn a lamp on and off, do be very aware of the fact that the power in the wires that run to your lamp can kill you. In most modern setups, there's a little bit of safety in place and it might just trip the breaker, but you don't want to make that assumption. I live in a very nice but old set of flats, and I do not want to test that on any particular daily basis. If you've ever been zapped with a non-life-threatening amount of current, but one that gave you enough of a jolt, you know that it's not something that you want to mess with. Be very careful with this stuff. Anyway, I'll disengage dad mode for a moment again. So this is a quad relay board with the Espressif ESP32 C6 as its brain. It's also as its connectivity port and everything that you want to do with it. As mentioned before, the specific combination of things that the C6 gives is quite interesting because you get that full connectivity through, Wi-Fi and Bluetooth, of course, yes, but Zigbee and Matter and Thread, but also the two ways of working with it. The high-powered 120 megahertz? No, I don't mean megahertz, do I? That's a lot of speed. I did mean megahertz, 160 of them. Sorry, it's very hot in the attic of dreams and my brain might not be working quite at its usual speed. And yes, and there's also the low power version of this as well, which is, I believe, the same core but running at a much lower ebb. The idea being that you could run it at 20 megahertz when it doesn't need to, say, communicate with the network very often, or if it just needs to wake up and do certain tasks. You can still have a very functional core doing things that will then wake up the main system to actually do things like communication and anything that takes a bit more power. It is also worth noting that when I say that this does give you Wi-Fi and Bluetooth, this is Bluetooth Low Energy 5.0 and Wi-Fi 6. And we've talked on the show in the past a little about how Wi-Fi 6 brings a number of advantages to Wi-Fi, putting it more in line with this sort of low power, quick wake up, quick communication, and the kind of location and packaging stuff that you can do with Bluetooth and other things. I've threatened it for a while, but at some point we really are going to have to do a Wi-Fi 6 deep dive on the Electromaker show, because it is still something that I understand the shape of and understand why it is so cool, but really need to understand it because everyone I've spoke to about it is very excited about it, and I share that excitement, but I would love to really understand it. Anyway, that's for another day. The I/Os and expansion is what I think most people will be interested in here, and you get the four relays, like I've mentioned. There are the pretty standard kind of relays that you get. They can go up to 240 volts at 10 amps. There's also 4 opto-isolated inputs that allow you to put up to 30 volts into it, which is a lot more current sensing going through the ADC than usual. Sorry, a lot more power going through the ADC than you would be usual. I'm so hot. I'd like to thank my makeup department for the glistening effect. It's a much higher voltage than you can usually put through the pins of a development board when you are working with, well, pretty much any chip. You also get 2 UEXT connectors. These are sort of general purpose connectors that give you I2C and serial RS232, I think, and SPI, if I remember correctly. You can plug in various things and it's a multi-protocol socket, essentially. And then an extension connector for more GPIOs, because the ESP32 C6 has a vast number of programmable GPIOs, general purpose ones. Strangely enough, general purpose input-output. The board itself also comes with a handy enclosure if it's something that you want to buy and then actually mount up on your wall or put somewhere accessible so you can feed wires in and out of it, as you can see here, and still have the USB-C programmable port out so that you can program it on the fly. Now, I will link the CNX software article in the description because it is where I read up on this board. And as I mentioned at the start of this section, there are various other ones that other development boards that feature this chip as well. And there is a small list of them in the body of the article. If you do also want to find a purchase link for it, it is currently available for a wonderfully low price of $13 on Tindy. Although at the time of looking, I think they were, I am absolutely wrong. I thought they were sold out. It turns out that they are not. So you can buy this directly from MakerGo on their Tinder page. On their Tindy page. And I will leave a link to that in the description of the video as well. There's a very niche but potentially $1 million app idea in there. It's just Tinder, but it's just development boards and things, embedded stuff, and you swipe whether you like it or not. No. Now, for those of you who thought I'd maybe got through a show without talking about a music-related project, I'm afraid you are mistaken. It is time to revisit simple DIY electronic music projects. Now, Kevin has been working for years on just a variety of wonderful microcontroller-based music projects, and anyone who's been watching this show for more than a couple of weeks knows that this is really where my interest in all of this is focused. It's my kind of focus point for all things like this. I got into microcontrollers so that I could start making MIDI controllers, and from there kind of learned a little bit about DSP. I'm still very much an amateur and someone who does not have much spare time, but it is exactly my passion, and it is clearly Kevin's as well, as he is the person who's behind the Lo-Fi Guide to the Orchestra, and also made a wonderful set of synthesizer modules fitted inside an upcycled IKEA CD rack. Among many other projects. But today I would like to talk about a project that he is starting, which is an educational synth package. The idea being that you can learn about synthesis using this very cheap tool, which is a great thing for people who can't necessarily afford to buy expensive synthesizers. There are many of these kind of things out there, but the thing I love about this project so much is that Kevin has taken us through the entire design process, which incorporates these other projects and talks about their strengths and weaknesses, and talks about exactly what Kevin wants to put into his. And this really is going to be one of those ones where I say, don't take it from me, head over to the website and take a look at it yourself, because everything on the DIY electronic music projects blog is really well cross-linked. It's very rare that you'll go through a page and see something that you don't understand, because usually he links to another page that explains it. Especially if you're going down the rabbit hole of trying to make music with the humble Arduino, if you come to this page and look for any of the Arduino-based projects, you will find in the body of those blogs links to the very basics of how to get started and up to the point of that blog. Kevin has made a very good decision making it work like this, and I wish more people did this with their documentation and blogs. Anyhow, this is part 1 to 6 of creating an educational DIY synth thing. Starting with the high-level principles and the idea behind it, talking about other kits, which has been updated to talk about different ones. During the process of doing this, he noticed that Erica Synth and Moritz Klein have just put out the Labor, which is a breadboard-based synthesizer worky-outy kit, which we will be coming back to talking about at some point in the future. I wanted to talk about it when it came out, but I waited because I had a little bit of a plan for how it might be a nice way to cover it, and that is taking time. Yes. And so from there you can go through, and he decided to use an ESP32 for the PCB, and you can see part 2 is a detailed design of the PCB and all of the ways he plans to use it. And again, one of the things that I love about this kind of documentation is that he notices while he's doing this, oh yes, there's strapping pins on the ESP32. If he could go back in time and start the design principles again, he may think a little bit differently about this, because it did create a few issues. So I highly recommend checking out the full write-up. There are 6 separate parts to it. Part 5 gives you 6 simple experiments to try with the full kit. And what you're hearing here is the little jumper cable that you're seeing right here being attached to different kinds of VCO generation. So that's a voltage-controlled oscillator. You can have square waves, sine waves, sawtooth waves, triangle waves. And this is attaching various things and twiddling knobs. And that is pretty much the entirety of modular synthesis. It does get much more complicated in terms of theory, but what you're doing is getting hands-on, plugging different cables into different things and twiddling knobs until it sounds cool. The beauty of this is a kit that you can build yourself, and it is very cheap. Part 5, gives you 6 simple experiments to try, and part 6 tries it out with a few different kits, including things like the Baby 8, for example, which is a fairly well-known project. There's lots of different versions. This is using a racket version, but yeah, it's a fairly common 8 8-step sequencer that you can use. It also uses some things from Mitch Electronics, which, by the way, if you're not familiar, I'll leave a link in the description. mitchelectronics.co.uk have a bunch of wonderful little electronics kits that you can put together. You solder them yourself. They're all very easy to use. They're all very well designed. And the name Mitch Electronics seems kind of familiar for some reason. And I can think of no finer way of closing out this sequence than with a little sequence from the Baby 8 here, albeit a very short one. But here it is again, sequencing the different VCOs using a gate to create different notes. Each one of these things is a fundamental building block of how synthesizers work, and this is a project that combines creating a synthesizer using a microcontroller, which is something I love, to make a functional finished product, which is something that I also love, with an educational focus designed to be understandable by all. This is probably one of my favorite things that Kevin has ever done, which is saying a lot, because he has been a very high kind of set the bar very high for people working with not a lot and making a lot out of it. So I highly recommend going and checking the DIYelectromusic.com blog. Also, he is active in our Discord server, which may be a good way to get in touch with him if you want to know anything about it. And he also has a Ko-fi page, which allows you to support him financially for the wonderful work that he is doing. And I highly recommend checking that out too. I certainly personally have learned a fair bit from Kevin over the years. That has been our show for this week. Thank you as always for joining me, and thank you for your continued support, whether that's by clicking like on this video, leaving a comment and subscribing, or buying things from the Electromaker shop. I am so happy to be back to a regularly sort of normal schedule. Life has been a little bit wild, but things are definitely calming down, albeit the heat is an issue, I'm not gonna lie, but the Attic of Dreams has a fan and I will cope. So yes, as always, I hope you're having a fun, safe and creative week. Please let me know in the comments if there's anything you'd like to see more of on the show, but for now, take care and I'll speak to you soon.